You know, in JavaScript, functions have this secret memory. And if you can figure out how to unlock it, you'll master two of the most powerful and sometimes tricky concepts in the language, scope and closures. So let's dive right in. All right, let's kick things off with a little puzzle. Take a look at this. We've got this function, makeWorker. Inside, it sets a variable name to Pete, and then it returns another function. Simple enough, but outside of all that, we have another variable, also called name, but this one is set to John. So the big question is, when we finally call that function we got back, what's it going to show, Pete or John? Keep that question in your head because we're going to have the answer by the end of this. So how are we going to get there? Well, here's the plan. First, we'll talk about the basic rules of visibility. Then we'll get into functions inside other functions. After that, we'll unpack this idea of a hidden backpack that functions carry around. And finally, we're going to tackle a few more code puzzles to make sure this all really clicks. Okay, first things first, let's talk about visibility. I mean, before a function can remember a variable, it has to be able to see it, right? And that whole set of rules for where variables can and can't be seen, that's what we call scope. And here's rule number one, the absolute foundation for modern JavaScript. Anytime you declare a variable with let or const inside a set of curly braces, any block at all, that variable is basically trapped. It's only visible inside that block. You can't see it from the outside. That's called block scope. And this right here really shows you the power of that isolation. Look at the left side. If you try to declare a message twice in the same global space, JavaScript throws an error. It's a conflict. But now look at the right. By wrapping each one in its own little block, its own curly braces, they become two totally separate variables. No conflict whatsoever. This is like a fundamental way we keep our code clean and organized. All right, so we've got a handle on scope. Now let's move on to a really common pattern in JavaScript, putting functions inside of other functions. Now, here's the really crucial part. A function that's created inside another one isn't totally isolated. It can actually reach outwards and see and use the variables from its parent function. It's kind of like a kid being able to grab a snack from the family kitchen, right? This ability to look outwards, this is the absolute foundation for what we call closures. Okay, but this brings us to the central mystery. Think about it. The parent function runs, it does its thing, and then it's finished. Poof, it's gone from the call stack. But it returned that little nested function to us. So later on, maybe much later, when we call that nested function from a totally different part of our code, how on earth does it still remember the parent's variables? Where are they even being kept? It feels like magic. Well, it's not magic, but it's close. The answer has a technical name, the lexical environment. But that sounds a bit intimidating, right? So let's use a much simpler analogy. Just imagine that every function carries around a hidden backpack. Okay, so when a function needs to find a variable, here's what the JavaScript engine does. Step one, it looks inside its own backpack, the local stuff. If it finds it, great. But if not, it moves to step two. It follows a link to its parent's backpack and looks there. Still not there? Well, it just keeps following that chain of links, going from backpack to backpack, outwards, until it either finds the variable or hits the very top, the global scope. And this is the secret sauce. When a function is created, JavaScript secretly attaches a hidden property to it. Think of it as a permanent, unbreakable link back to the backpack of variables that existed at the very moment it was born. It's like a birth certificate that says, this is where I come from and I will always remember it. Okay, so we've talked about scope, we've seen how functions can be nested, and we've unpacked this idea of the lexical environment or the hidden backpack. With all those pieces on the table, we can finally put a proper name to this amazing behavior. We're ready to define what a closure actually is. So what is a closure? It's simply a function that remembers its outer variables. It remembers that hidden backpack from where it was created. That's it. And here's the really wild part. In JavaScript, this isn't some special feature you have to enable. By their very nature, all functions are closures. Every single one of them has this built-in memory. The classic make counter example is just perfect for seeing this in action. When you call make counter, it creates a new backpack, and inside it puts a variable, count, set to 0. Then the function it returns has that permanent link back to this specific backpack. So even after make counter has finished running and disappeared, that return function can still reach into its own little private backpack and find and update that count variable. That's the closure, right there. All right, enough theory. The best way to make this stuff stick is to actually use it. So let's solve a couple of classic code puzzles. See if you can predict what's going to happen based on everything we've just covered. Okay, check this out. We call make counter to create counter, and then we call it again to create counter 2. We run counter twice, so it alerts 0, then 1. Now, for the real question, what happens when we call counter 2 for the very first time? Does it pick up where counter left off and alert 2, or does it start fresh from 0? The answer is they're completely independent. Counter 2 is going to alert 0, and why is that? It's because every single time we call make counter, it manufactures a brand new, totally separate hidden backpack with its own fresh count variable inside. Counter has its backpack, and counter 2 has its own backpack. They don't know about each other at all. Okay, now for a real classic, a true brain teaser that trips up a lot of developers. This make army function loops 10 times and creates a shooter function in each loop. Now, you'd think, logically, that calling army of 0 would alert 0 and army of 5 would alert 5, right? But they both alert 10. Every single one of them alerts 10. What on earth is going on? Here's the trap. All 10 of those functions were created in and are sharing the exact same lexical environment. They're all sharing one single backpack, and inside that one backpack, there's only one variable I. By the time we actually call any of those functions, the loop has long since finished, and the final value of I is 10. So when they look in their shared backpack for I, that's the only value they can find. Thankfully, the modern fix for this is so simple and elegant. You just use a for loop with let. Now, for let I is special. It has this built-in magic where it creates a brand new backpack for every single trip through the loop. So each shooter function is born in its own private environment, and it remembers its own unique value of I from that moment. And just like that, problem solved. And this really hammers home a key point. A closure doesn't take a snapshot or a copy of a variable's value when it's created. No, it holds a live direct link to the variable itself. So when you finally call the function, it goes and checks what the value of that variable is right now. Okay, so let's do a super quick recap. Scope is all about where your variables can be seen. The lexical environment is that hidden backpack that holds all those variables. And a closure, that's just a function plus its backpack. And remember, this isn't just academic theory. This is the mechanism that powers awesome, practical patterns like private data and function factories. And with all that, we can finally go back and solve our very first puzzle. The answer? It's P. That global name variable John is a total red herring. It doesn't matter. The work function was born inside make worker. So it carries that permanent link, that hidden backpack from that environment. And in that backpack, name was Pete. It doesn't matter where or when we call it, it will always remember where it came from. So when you think about it, functions in JavaScript are more than just bits of code. They're code with memory attached. They have a history. Now that you see how to give your functions a past they can remember, the real question is, what kinds of new and powerful things does that let you build in your own code?